Hi everyone. Today we're going to be talking about perfect squares and how they can be used to break down square roots without the use of a calculator. So we kind of talked about this yesterday in class. We made a list of our perfect squares up through 10 squared, which is 100. So if you look at my list here, 1 to the second power, of course, is 1 because 1 times 1 is 1. 2 to the second power is 4 because 2 times itself is 4. And this just keeps on going. So my perfect squares are what's circled in blue here. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Those are all examples of perfect squares. I could do this for the next 5 hours. I could do 11 squared, 12 squared, 13 squared. There are actually an infinite amount of perfect squares in our number system. It's just in this class we'll be working pretty much with numbers in this area. So those are the only ones I included. Okay, so what do we need these for? Well, if you take a look at your note sheet, which is titled Simplifying Square Roots, it says complete all work by hand, no TI-84 allowed, no decimal answers. Okay, now I'm going to break that rule in number 3, but I'll show you that a little bit later because that's going to be a test-taking strategy. Okay, so take a look at example 1. It just simply says simplify the square root of 12. Now your gut instinct might be, hey, Miss Callahan, you made me get this calculator here, and I know where the square root button is, so I'm just going to press second x squared to bring up the square root. I'm going to punch 12 in and hit enter, and there's my answer, 3.464. And you're right, the square root of 12 is 3.464. If you would take this number times its very own self, you would get right back to 12. Okay, but this says not to do that. They don't want a decimal answer. So there's another way you can break down a square root, and it involves using your perfect squares. So what you want to do is you want to take your number that's under the root, in this case 12, and you want to list out as many factors as you can think of for that number. So factors of 12, for example, 2 times 6. 2 and 6 are factors of 12 because when you multiply them together, they equal 12. Can you think of another pair? Maybe 3 times 4. And I think that's about it, since 12 is a pretty small number. Okay, so you look over these factors, and then what you want to do is see if any of those factors are on your perfect square list. So I'm looking for a 2. Okay, I jumped from 1 to 4, so 2's not going to be one, so I'm going to cross him off. 6, 1, 4, 9, nope, between 4 and 9, there should be, if there was a 6, it would be here, so 6 is no good. 3, nope, no 3, and 4, bingo, 4 is on the perfect square list. And more importantly, the square root of 4 can backtrack right here to this base. The square root of 4 is 2, just like the square root of 9 is 3. So this is going to be the magical pair that we can use to break this down further. So from here, we're going to actually come under our square root of 12, and we're going to rewrite it as the square root of 4 times 3. Now, if you don't believe me that these are the same, check it out on the TI. If I type in my square root symbol and then underneath there 4 times 3, you see I still get the same thing, 3.464. So this is legal. Okay, my next step is I'm actually going to break these two square roots apart. I'm going to write this as the square root of 4 times the square root of 3. That's legal, and I'm going to show you how that works. Let's look at it. The square root of 4, now I got to kick out, put my times sign, and then separately I'm going to type in the square root of 3. Same answer, so we're looking good. We keep getting that 3.464. We're just breaking it down. Okay, final step of this problem. 4 is our perfect square. The square root of 4 is 2. So I'm going to write that down. The square root of 4 is 2, and notice the square root goes away because when you do that operation, you just get 2. This guy, square root of 3, see, he's not perfect. 3 is not on our perfect squares list. So we can't do anything with him. Even if you try to do square root 3 on your calculator, it's going to be some ugly decimal. So we just leave him under the square root, kind of click and drag him down for our final answer. So the final answer to this problem is 2 square root 3. So we have simplified the square root of 12. So we started with the square root of 12. We've simplified it to 2 square root 3. This is considered simplified without a calculator because there is no decimal. And last but not least, if I type in 2 square root 3, there it is. It was the same answer as I started with, 3.464. Okay, let's go on to example 2. This one's about the same. It's just a little bit more complicated because I've put a number outside here. I put this 7 in front of the square root of 45. Okay, so here we go. Let's start with the 45 and let's start listing out our factors of 45. So we have to think of numbers that multiply together to give 45. Now, if you're not the greatest with your multiplication tables, that's okay. You can use the TI to figure that out. Anytime you want to find factors of a number, start with the number, so 45, and just start dividing it by 2, 3, 4, etc. And you'll find your factor pair. So like, for example, 45 divided by 2, nope, it's a decimal. 45 divided by 3, there we go, 3. So that means 15 times 3 is 45. So I'm going to put that down, 15 times 3. Okay, let's do 45 divided by 4. Nope, decimal. 45 divided by 5. Yep, 5 times 9. 5 times 9. Okay, 45 divided by 6. Nope, decimal. 45 divided by 7. Nope. 45 divided by 8. Nope. 45 divided by 9. 5 times 9. But we already have that pair. You always know you're done finding your factors when you start to repeat factors. So we already have 5 times 9, so we just have these 2 sets of pairs. So let's compare our factors to our perfect square list. Slide this over here. Okay. Is 15 on the perfect square list? Definitely not, because we jumped from a 9 to a 16. 15 would be in there, and it's not. So 15's no good. How about 3? Nope, there's no 3. So this set's done. 5 would be here. Nope. 9. Bingo. 9 is right there. 9's the winner, so we're going to take this pair of factors. All right, we're going to slide that over underneath the problem. So what I have now is 7 on the outside and the square root of 9 times 5 on the inside. From there, I'm going to split this up into 2 different roots. So I'm going to bring the 7 down, square root 9 times square root 5. Okay, I'm going to come over here since I'm out of room. Now, the square root of 9 is 3. How do I know that? Well, I know that 3 times 3 is 9, but if you forget, come down here, here's my 9. I know that the square root of this number is this base over here, which is 3. 3 times 3 is 9, so the square root of 9 is 3. So I'm going to have my 7 and times 3, which is the square root of 9. Now the square root of 5 is not perfect because 5 is not a perfect square. So I'm going to have to leave him underneath the roof, tucked inside because he's a decimal. And my last step is to actually multiply the 7 and the 3 together. So I'm going to say 21 square root of 5, final answer. And to check it, I can surely type in the original problem, which was the square root of 45. So that decimal is 6.708. And if I type in my final answer, 21 square root 5, I should get the exact same. Oh, okay. I see what I did. Do you see what I did? I'm like, why are they different? I forgot to put the 7 out in front here. Redo. Okay, the original problem, 7 square root 45. See, teachers can make mistakes too. There we go. My simplified answer, 21 square root 5, same thing. Okay, that makes me feel so much better. All right, we're going to end this video here, but tune into the next video to finish up examples 3 and 4.